Hi friends, welcome to learn fundamentals of data structures and algorithms course. Performance analysis of an algorithm. In the last session we have discussed the performance analysis of an algorithm using step count method. The performance analysis of an algorithm is defined into two categories. One is the space complexity, second one is the time complexity. Time complexity defines how much amount of computational time is required to complete the execution of the algorithm. To find the time complexity of the algorithm, we need to find the total number of execution steps of the algorithm. To find the total number of execution steps, to find the total number of execution steps of the given algorithm, we have two methods. One is a step count method, second one is a step table method. In the step count method, we have defined a global variable count. Global variable count is defined. The global variable count is initially set to a value 0. Whenever we have an executable statement or the corresponding instruction step, a program step, we need to increment the count by 1. Count is equal to count plus 1. Having the initial value of count as 0 and incrementing the count by 1 whenever we find any executable statement or program step. Finally, we need to find a value of count so that we can find the total number of execution steps. Total number of execution steps in the given algorithm. This is step count method. The second way to determine the total number of execution steps in the algorithm is step table method. Step table method or a tabular method. As the terms imply, we need to construct a table so that we can easily find the total number of instructions of the given algorithm. Compared to the step count method, we can easily construct the table so that the total number of execution steps of the algorithm can be computed easily. In this step table method or a tabular method, we need to construct a table. The table in which we need to specify some columns. The columns are algorithm, that means this is the name of the algorithm. Then we need to construct a column steps per execution, S by E, which means step per execution. Next column, constructing the frequency and the next column we need to find the product of these two steps per execution into frequency. So, we need to construct a table like this. In the first column, write the complete algorithm. Second column, specify step per execution. Third one is frequency, and the next one is the product of these two columns, S by E and a frequency. Second column, write step per execution. Step per execution is the amount by which count changes as a result of execution of that statement. Suppose consider here one statement S1 is there. Consider a statement S1 is available in the algorithm. We need to find the program step for the statement S1. What is a program step? Program step is syntactically or semantically a meaningful segment of the program that has an execution time that is independent of the problem instance characteristics. So, when S1 gets executed, we need to associate the corresponding count, how count gets affected or how much, right, the variable count will get incremented. So, the amount by which count changes as the result of execution of that statement S1. When the statement S1 is executed, in the step count method, we have focused on incrementing the variable count. How much quantity count will get affected, that should be specified in the column step per execution. In case suppose x is equal to y, this is a simple assignment statement. The simple assignment statement x is equal to y, execution takes one time execution. So, count is incremented by 1, count is equal to count plus 1, right, one time increment. So, step per execution is the value 1. 1 indicates that count will get incremented by 1 because of the execution of x is equal to y. The next column is frequency, a frequency which indicates that the number of times the statement say S1 is executed. Number of times the statement S1 is executed, that is a frequency. So, for each executable statement, find the step per execution value and the frequency like this. We need to complete the columns step per execution and frequency. Then in the last column, find the product of these two entries, then find the sum of the quantities in the last column. This indicates that this total indicates that the total number of instructions or total number of executable steps, of the algorithm. So, to find the total number of executable steps of the given algorithm, we need to construct a table like this: algorithm, step pair execution, frequency, and step pair execution into frequency column. Find the sum of last column, so that we have the total number of execution steps of the given algorithm. Now, let us apply the step table method to find the total number of execution steps of the sum algorithm. Example 1, sum of array, the name is sum algorithm. Writing the algorithm sum A array comma n. What is A array? This is the one dimensional array which consists of n elements. The size of the array is n. We need to find S is equal to A1 plus A2 plus A3 plus etc. an. Writing the algorithmic instructions here, setting S is equal to 0, then for I is equal to 1 to n do S is equal to S plus A of I for n's here and for, then after the execution of for loop, return a value of s, return s. This is the end of algorithm sum. Given there are n elements in the array a1, a2, a3 etc. an, we need to find the expression s is equal to a1 plus a2 plus a3 plus etc. an. As we have designed earlier, the same iterative algorithm is written here. S is equal to 0, for I is equal to 1 to n do S is equal to s plus a of I, and for return s, then the end of the algorithm sum. So, in the step table method, the first column has been constructed, algorithm. Second column is step pair execution. So, writing the second column here, step pair execution. First column algorithm name, second column a step pair execution. For example, here this is algorithm, first column, second column step pair execution, third column frequency, next column step pair execution into frequency. Now, we need to construct the table like this. a table columns are constructed. Finding the step pair execution, first right, this is the name of the algorithm, this is not an executable statement, so simply put hyphen. Second and third lines, these are comments, so simply put hyphen. Opening curly brace, I put hyphen or dash. Next statement, s is equal to 0. S is equal to 0, this is an executable statement. This is taken as one step pair execution. When s is equal to 0 is executed, count should be incremented by 1. So, associated count is equal to count plus 1. So, the step pair execution value of s is equal to 0, the simple assignment statement is 1. That means count is incremented by 1. Then for I is equal to 1 to n do, in the for loop we need to consider the program step for only the conditional part, control part, checking if I less than or equal to n. This is the conditional part of the for loop. So, checking if I less than or equal to n, this is taken as one step pair execution. So, step pair execution value is 1. Then s is equal to s plus a of I, a simple assignment statement. This results in count increment of 1. So, step pair execution is 1. End for, you simply write put hyphen, then return is an executable statement. We should have increment the associated count before the execution of the return statement. Count is equal to count plus 1 and then execute return is. So, return is the corresponding step pair execution is 1. Now, considering the frequency column, s is equal to 0, a frequency which indicates that how many times the statement is executed during the execution of the algorithm. S is equal to 0, a simple assignment statement. When the program begins its execution, the statements are executed in the sequential order. Clearly, s is equal to 0 is executed only one time, hence its frequency is 1. Then for I is equal to 1 to n do, checking the condition I less than or equal to n. We have already explored the conditional test I less than or equal to n is tested for n plus 1 times. When I is equal to 1, it checks the condition. I is equal to 2, the condition is tested. I is equal to 3, checking if I less than or equal to n is done, etc. When I becomes n, I less than or equal to n is tested. When I becomes n plus 1, I less than or equal to n is also tested. In the last stage, the result of execution of I less than or equal to n plus 1, I is equal I less than or equal to n, that is n plus 1 less than or equal to n, results in false. So, the condition I less than or equal to n is tested for n plus 1 times, that is the frequency value of this conditional test I less than or equal to n. So, putting the frequency as n plus 1. S is equal to s plus a of I is executed for n times, because in the last stage when I becomes n plus 1, n plus 1 less than or equal to n, condition is false, control comes out of for, so that this assignment statement will not get executed. So, for loop condition is tested for n plus 1 times, but the part of for loop is executed for n times. So, here put frequency as n, then n for right hyphen return yes. Since the statements are executed in the sequential order, return is executed for only one time. So, frequency is 1 here. This is a frequency column corresponding to this algorithm sum. Now, finding the last column, right, find the product of step pair execution and frequency. 1 into 1 1, 1 into n plus 1 n plus 1, 1 into n n, then hyphen 1 into 1 1. So, finding the result of last column, we have n plus n 2n, 1 plus 1 plus 1 2n plus 3. What is this? T, time required to complete the execution of algorithm sum with problem instances n is equal to 2n plus 3. So, total number of execution steps in the sum algorithm is T sum of n is equal to 2n plus 3. The same result that we have obtained earlier using step count method. So, comparing step count and step table method, there right we need to predict what will be the final value of count. Here, since we know that for each statement we know right the frequency of execution of that statement. So, it is better to construct the columns step pair execution and frequency, so that we can easily find the total number of execution steps of the algorithm. Understand? So, clearly T sum of n is equal to 2n plus 3 execution steps. This results in order of n or a theta of n, a linear computational complexity. Second problem, let us find the total number of execution steps in the recursive sum of n numbers algorithm. Recursive sum of A array comma n. This is the recursive algorithm to find the sum of n numbers stored in an array. It also evaluates S is equal to A1 plus A2 plus A3 plus etc. plus An. First, write the algorithm in the first column. Here, checking if n is equal to 0. If n is equal to 0, then return 0, else return a recursive sum of A array comma n minus 1 plus A of n. If else, if ends here and if, then opening curly brace, closing curly brace, this is the end of recursive sum algorithm. Checking if n is equal to 0, the value 0 is returned, else the recursive procedure is called recursive sum. Actual parameter is initially a array comma n. Here in the next recursive call, the actual parameter is a array comma n minus 1 and the nth element is separated. Let us construct the columns. First column algorithm, a second column step per execution, a third column frequency, last column step per execution into frequency. Now let us find the column values, step per execution, frequency, then step per execution into a frequency. Constructing the table like this. Now consider the first line, this is hyphen, hyphen, second one hyphen, opening curly brace, hyphen. If n is equal to 0, checking the condition, right, is taken as one step per execution. Please recall that in the step count method, we have introduced the count before the if statement corresponding to the conditional test if n is equal to 0. So, if n is equal to 0, right, this is taken as one step per execution, corresponding count is incremented by 1. So, here the step per execution value for this conditional statement if is 1. Return 0 returns a value 0 to the calling place, taken as one step per execution, because before return 0 we have incremented the corresponding count is incremented by 1, hence step per execution value is 1. Then considering this return statement, right, in the else part, return recursive sum a array comma n minus 1 plus a of n. This case, carefully write, understand, this is not a simple return statement. In case return 0, the value 0 is returned, right. So, simply it takes s by e value of 1. However, this return is a recursive procedure. Since the algorithm name is recursive sum, here also the name is recursive sum. If we write the computational time for recursive sum of a array comma n as a t recursive sum of n, here we need to find the computational time to find the recursive sum of first n minus 1 elements, since the nth element is separated and added with the return expression. So, just to think, if a t represents the computational time for the recursive sum algorithm with the input size n. That means a t recursive sum of n represents the computational time to find the sum of first n elements in the array, or sum of n elements in the array. this recursive sum of a array comma n minus 1 have a significant of a t recursive sum of n minus 1. That means the computational time of this recursive sum a array comma n minus 1 is t recursive sum of n minus 1. This is important. Assuming the t recursive sum of n minus 1, this value is say x. Let x represents the computational time of a t recursive sum of n minus 1. That means S is equal to a1 plus a2 plus a3 plus etc. a n minus 1. First n minus 1 elements addition is defined using this recursive sum. Computational time is t recursive sum of n minus 1. Let it be equal to x. Assuming a return right this recursive sum a array comma n minus 1 value is obtained. This is added with a of n. Since return right this expression is taken as one step per execution, putting 1 plus yet to find the recursive sum of a array comma n minus 1. That computational time is x is equal to t recursive sum of n minus 1. So that I write here 1 plus x. So step per execution of this return statement in the else part is 1 plus x, where x is equal to a t recursive sum of n minus 1. Understand? Then end if hyphen a closing curly brace hyphen. Step per execution column is constructed. Next we need to find the frequency column. To find the frequency column, since if else a conditional test is there, based on the value of n we need to find the frequency, because when n becomes 0 recursion is terminated. To terminate a recursion, when n becomes 0 the value 0 is returned to the calling place. So to find out the frequency exactly, construct two columns, one when n is equal to 0, second when n is greater than 0. So separate the frequency into two columns, n is equal to 0 and n is greater than 0. Now consider these algorithm, a comment line, opening curly brace, first 3 lines, hyphen, here also first 3 lines, algorithm, comment line, opening curly brace, I put hyphen. If n is equal to 0, since if the condition is when n is equal to 0, right, if n is equal to 0 the condition is true. So how many times the frequency is tested means one time the frequency is tested. So frequency of if n is equal to 0, right, this is 1 when n is 0. If n is 0 the condition is true, then return 0 is executed. Return 0 takes step per execution 1, the frequency is 1. This is the case when n is equal to 0, because when n is equal to 0 the true part is executed. This is the true part. Else, right, this is the false block. Since n is equal to 0, right, there will be no execution in the false block. So here put hyphen n is equal to 0, then end if a closing curly brace hyphen. Understand? Now consider the case when n is greater than 0. If n is greater than 0, n is equal to 0 is tested if n is equal to 0. So, step wire execution when n greater than 0 is also 1. Return 0 when n is greater than 0, if condition becomes false, if the condition becomes false, return 0 is not executed. So, here the frequency we should put 0. 0 indicates that return 0 is not executed when n is greater than 0. Now, control goes to execute the else part. Else return recursive sum of a array comma n minus 1 plus a of n. When n is greater than 0, condition is tested, condition false. So, frequency 1 is associated here, then return 0 is not executed. So, frequency is 0, control goes to execute the false block, else return recursive sum of a array comma n minus 1 plus a of n. Even if this is the recursive call, recursive sum a array comma n minus 1, here how many times this return is called means during the execution of the algorithm, this returns is called only one time. However, this recursive procedure is called many times. Return invokes recursive calls, or return invokes a recursive call which may invoke a further recursive calls based on the value of n. So, the frequency of this return statement, you have to think how many times this return is executed. Main algorithm, that means the main function call return is executed. As a sequential execution is taken place, this return is executed for one time. So, when n greater than 0, the frequency of this return statement is 1. Then end if hyphen closing curly brace hyphen. So, we have constructed the frequency for two cases, one when n is equal to 0, second when n is greater than 0. In the same way, last column should be split into two, one when n is equal to 0, second when n is greater than 0. So, constructing the columns n is equal to 0 and n greater than 0. Now, the step wire execution column is multiplied with the corresponding frequency column when n is equal to 0. First 3 lines hyphen, then consider these entries, 1 with this 1, 1 into 1 results in 1, 4th line, then 5th line 1 with n is equal to 0, 1 into this 1 results in 1, then 1 plus x into this one when n is equal to 0. That means here hyphen is introduced, which means 0, since when n is equal to 0, this else block is not executed. So, put 0. So, 1 plus x into 0, this is 0, here hyphen, here hyphen. Likewise, consider step wire execution column with the column n greater than 0 and write the product in this column when n greater than 0. It seems first 3 lines 1, 2, 3 hyphen, A fourth one, this one, right, step per execution, this is multiplied with this one. So, writing right 1 into 1, 1, then step per execution, right, this one is multiplied with this quantity 0, results in 0. Then 1 plus x is multiplied with this n greater than 0, 1 plus x into 1, this results in 1 plus x. End if right hyphen, then a closing curly brace hyphen. So, we have found, right, the S by E into frequency column. It has been, right, split into two columns, one when n is equal to 0 and the second one when n is greater than 0. Now, let us find the sum of last column. Since we have two cases, we need to find the sum for when n is equal to 0. When n is equal to 0, the sum is, right, 1 plus 1, this is 2. When n is greater than 0, sum is 1 plus 0 plus 1 plus x, which results in 1 plus 1, 2, 2 plus x. So, the last column, which signifies that the termination condition when n becomes 0, the total number of execution steps is 2. When n is not equal to 0 during the recursive call, it seems that the total number of execution steps is 2 plus x. So, writing the value of 2 and 2 plus x with this time complexity notation, a t recursive sum of n, we have t recursive sum of n, this is equal to, what is the last column, 2, this is when n becomes 0. So, a t recursive sum of n is equal to 2 if n is equal to 0. A 2 plus x when n is greater than 0, writing here 2 plus x if n is greater than 0. What is x here? X is return 2 plus. X represents the computational time to find the sum of n minus 1 elements in the array. X is equal to a t recursive sum of n minus 1. So, substituting the value of x here, a t a recursive sum of n minus 1. So, when n is equal to 0, the total number of operations performed by the algorithm is 2. When n is greater than 0, total number of operations performed by the algorithm is a 2 plus a t recursive sum of n minus 1. The same recurrence relation, is obtained using the step count method. In step count method, we have obtained the same recurrence relation, a t recursive sum of n is equal to 2 if n is equal to 0, a t recursive sum of n is equal to a 2 plus a recursive sum of n minus 1 when n is greater than 0. And we have also applied the substitution method in finding the solution to this recurrence relation. Understand? So, if the algorithm involves the conditional part like this, if statements, if, conditional test, else, try to construct a table for the required conditions, say n is 0, n is greater than 0, right, n is less than 0, n is greater than 0. Likewise, the frequency column, right, should be constructed. Then split the required number of columns equivalent to the frequency in the last column, step wise execution into frequency, so that we can find the termination condition count and the recursive condition count separately.